All right, Chapter 2 Summary. The chapter presented with the information on the logical fundamental logic of the Boolean laws and theory of the information valve with a summary of the important points of the chapter, the logical development, the logical conclusion based on the non-information computers to operate with the assumption for the statement of the two conditions true and false. Positive logic is defined as valve with a signal that activates with the trigger that is one state with its voltage level of positive, then zero state with the logic polarity is considered to be positive. Negative logic is defined as valve with a logic a signal that activates another one state as a voltage level of more negative than the zero state with the logic zero state logic polarity is considered to be negative. The digital logic positive and negative with the true condition statement is represented with the logic state 1, the false condition represented with the logic state 0. Logic level of high and low represent the low voltage level of the two logic states, with the logic level of high represent the most positive voltage, while the logic level of low represents the least positive, the more negative voltage. For the post positive logic high level that correspond with the true or one state or one state, the low level that correspond with the false and zero or false state. The negative logic high level corresponds with false, zero state with the low level that correspond with the true or one state. The Boolean expression of the statement that represents the input output logic gate with the and or and gate requires all input for the high and same time in order to produce the high output. The OR gate requires one of both input for the higher in order to produce the higher output. Inverter does not function from the negative to or with the logic gate with the U with the complement with the state with the input with the variable with the 1 becomes the 0, though 0 becomes 1, and maybe U with the input with the output with the AND gate with the output same with the desired result. All right, so here is your inverter and amplifier inverter on the bottom. Not AND gate with the function with the AND gate with inverted output. They show the AND gate, not AND or gate with the function with the inverted output. They show the and not or gate is we deprive the output Boolean expression combination with the gate solve one gate at a time. Boolean algebra is used primarily for the design and simplification of circuits.